So we're gonna talk about your chapter 10. This is the last chapter for your class here. So if you have any questions, type on the chat room. Any questions for me? Okay. This is talking about chapter 10. We'll talk about chapter 10 here. So you have questions, do let me know. So I'm going to share the screen and it's start recording. Again, it will be posted in D12, this video. So I'm going to share the screen right now. So this is chapter 10 here. So chapter 10 is talk about correlation and regression. This is where we got a pair of sample data. So in the test, it's very obvious if this comes from chapter 10, they will have the word correlation and they have the word regression here. So if they give you a pair of sample data, and then what happened is that they want you to find the correlation here and then the regression. So this correlation means that the two variables is associated between each other. In order for us to have a linear correlation, this is what we were talking in chapter 10. A linear correlation means that when you guys draw your scatter plot, it shows a straight line. Okay, if not showing a straight line, then and then either if you have a scatter plot like this, which is all scattered, this is still considered linear. I just want to point out to you guys. And if you have all this, this is also linear. So what is considered not linear? Not linear means if your scatter plot shows me a curve like that or exponential. So anything that is not a straight line, like a parabola or something else, this is not non-linear in this case. And if you got this in your scatter plot for this class, chapter 10 does not work here. So that means that if you do your scatter plot and you got this, 10.1 and 10.2 will not work in this case. Okay, so that means that you just tell me that this is not a linear case. Doesn't apply. You have to go to another statistic class to learn the non-linear case here. But in this case, everything we learn here are all linear case. So that's why we will, so the whole chapter 10 has to be linear. So linear means straight line. It can be scattered like this. This is still considered linear. I just want to point out to you. And if you have this, it's also linear. We have a positive linear correlation. A positive correlation means your slope is going up. You know slope. For a negative correlation means your slope is going down. And if you have a scatter plot like this that is all filled up, scattered like this is called no linear. Okay, but not a linear correlation. Okay, we use the letter R for linear correlation, and then this is for sample statistics, and then we use the symbol rho for population. As you guys know that we got sample mean and the population mean, so we have a sample correlation and a population correlation. So one is R and one is rho. The properties of it is your R can only take number from -1 to 1 inclusively, means that your R can be -0.6, 0.8, 0.02, but your R cannot be 5, 3, -2.8. So your R value has to be between these two numbers. What happens if your R is exactly 1? Because R can be exactly 1. If your R is exactly 1, this is the picture. If your R is exactly 1, your line is all, your dots is all straight. This is R is 1. When R is 0.9 or 0.7, you find out that your scatter plot is a bit scattered like this. We call it as strong. If it's exactly, we call it perfect. If you find out that your points a little bit scattered, more a bit scattered than the 1, so it's called a moderate string. This is all linear here. Your R is between 0.4 or 0.6 here. Okay, and once it got to scatter a little bit, then we call the correlation R weak. It's between 0.3 and 0.1. And when you got everything scattered like this, we call it as not a linear correlation. Your R is 0, and you find out that this is a bit more scattered in this case. Okay, so no matter what you have here, this is called linear. So you are able to continue doing it. This is all positive is because your slope is positive. So when you have a downward slope, then your R in this case will be negative. Okay, so this is what we call as your properties. Your R is between negative and 1. If you change the values to a different scales, your R does not change. So what does that mean when I say if you change to different scale? Let's say that this scale is all in kilometers, but I want to change the kilometer into miles. So I will multiply all of them into the conversion from kilometer to miles. Your R still the same if you convert them to different scales. So that is the meaning of the second property. If you interchange your X and Y, that means if you flip your X and Y around, your R is not affected. So this is your X, this is your Y, right? So if you switch your X and Y around, your R is still going to be the same. Okay. Then R in this case measure the strength. Strength means it can be perfect, it can be strong, it can be moderate, it can be weak, and it can be no. So these are the strength in this case. And R is very sensitive to outliers. Okay. Requirements is pair data. So pair data means it comes from one person, but you give me two data. So example is if I want to collect you based on your height and your weight. So that's called pair data, means one of you guys will have to give me two data, a pair we call it. One is your height, one is your weight. It has to be simple random sample and it has to be quantitative. So R will not work if you give me like categorical, like your height and your gender. So if you talk about height and gender, that doesn't work because gender is categorical. So it's not quantitative, so we cannot find R in this case. So make sure that when you do R, two of them has to be quantitative, cannot be categorical. Okay. You have to draw the scatter plot, and the scatter plot must show a straight line. So straight line pattern will be all this. This is a straight line pattern. This is a straight line pattern. This is a straight line pattern. All these are straight line pattern. The only thing that is not a straight line pattern is when you get yourself a parabola like this or not a straight line. This is not a straight line pattern. And what do I tell you when you have no straight line pattern? You cannot use chapter 10. You just tell me that this is a non-linear correlation, so that's no good. Okay. If you have outliers, you have to remove your outliers because R is very sensitive to outliers. So how do you figure out outliers in this case is if you have a scatter plot like this, if you have so these are all your points. If you have one point that lies up here, this is considered outliers. So again, this is a scatter plot. If you have a data right here outside this, then it's considered outlier in this case. But if you have a scatter plot and if you have a dot right inside here, this is not an outlier because it's still inside here. But if this dot is way up here, this is your dots, these are your dots, and you have a dot way out here, then that is your outlier. So outlier only exists if they are very far away from your data. So if this is all your data here, and you've got one data point out here, or your one data point way up there to the right, or way up here, then these two are considered outliers. This is not outliers here. Okay, so usually if you have these outliers, we remove them. Okay, if you have this, we remove the outliers, and then you just concentrate on these points. Okay. In the beginning of chapter in the class, we always say that correlation does not imply causality. The reason why this is more important. Correlation does not imply causation. The reason why is because of looking variables. Okay, what is looking variables? Looking variables are variables that we did not study we did not include in the study, but it will affect the variables. Example in this case is let's say you talk about two things. Your test score and your attendance. We talk about this a lot. We know that if you come to class a lot, not now, but if your attendance going up, we know your test score will goes up, right? Can you say that your attendance will cause your test score to goes up? The word cause here, no, we cannot say that attendance cause your test score to goes up. The reason why we cannot use it is because looking variables. Can someone tell me what other factors will cause your test score to goes up beside attendance? That's a lot, right? That is a lot of variables that might cause your test score to goes up. So like what? Your homework score, right? How much time you spend on your on your work, how much time you sleep, right? Those are a lot of other factors that we did not study. Those are what we call lurking variables. So lurking variables are those that we did not study did not include in the study, but it will affect the other variables. Okay, so that is called the correlation here. How do we do our testing hypothesis? Now, if you remember last time in chapter 8 and 9, we had to write all the 6, 7 steps to do hypothesis testing. In this case, you do not need to do it, or you just need to do 2 steps. First step is writing your statement. H0 is rho equals to 0, rho not equals to 0. This is rho, not P. It's a population correlation. If rho equals 0 means there is no linear correlation. If P rho not equals 0, there is a linear correlation. And then after that, you look at your decision. If a p-value is less than alpha, there is a linear correlation. If p-value is greater than alpha, there is not a linear correlation. So this is a very straightforward type. You do not need to write give me the p-value and everything. So straightforward type, it's very short. To do your testing correlation, you only need to do 2 parts here, not 6 parts. Okay. So what we did so far is all in 10.1. So 10.1 is asking us to find R and then do what we call as a correlation here. And then 10.2 in this case is we will talk about regression equation. So regression equation looks like y equals to mx plus b, but we don't use that anymore. We will use this y hat equals to b0 plus b1x. The reason why we do not use y equals to mx plus b that you guys learned in your previous algebra class is because in your previous algebra class, you only get 2 points, right? I give you 0.1 and 0.2, and then, oh yeah, I can find the straight line using y equals to mx plus b. Yes, that is correct. But in this case, you don't have 2 points. You have what? You have a lot of points here, right? So when you draw me the straight line here, this straight line is what we use as the y hat. And the reason why you need a hat here is because this is a prediction. So the line that you draw here is just a prediction. It's just like an estimate. So like when you go to fix your car in the mechanic, they just give you an estimate. Oh, this is going to cost you around $500. It's an estimation. So that's what we are doing here. In this case, it's an estimation. The y that we use here is not called predicted. That's called the actual. Okay. So again, how do we know which one is your slope? Is the one next to your x. Like last time, remember, anything next to x, your m, your slope. So in this case, b1 is next to your x, that's your slope, and b0 is your y-intercept. Okay. So this is called a regression line, line of best fit, least square line. So they have a lot of names for this, but they're all regression equation. They're all not the same. They're trying to find this. And then usually what is the purpose of us finding this regression equation? The purpose of finding regression equations is to make prediction. What do you mean by prediction? Prediction means we substitute x to become a number, and then you plug it into the equation, and then you find y. So once you get this regression equation, say, what happens if you have 10 students? So my x is 10, so I plug 10 in this case, then I can figure out what is the prediction in this case. You can only use this substitution of x if you have a good model. So what is considered a good model? In order for us to consider a good model, you have to fulfill these 3 conditions. So if all these 3 conditions is satisfied, then you consider a good model. So what is the 3 conditions? First condition is your scatter plot has to fit the points straight line, okay, linearity. So your scatter plot should have to form a straight line, a linear line. And then you have, the second condition is you have to have a linear correlation. A linear correlation means if you have to look at p-value, your p-value has to be less than alpha. And next thing is there is no extrapolation. What is extrapolation? Extrapolation is you try to predict something that is beyond the scope, okay? Example is, let's say you want to try to predict the gas price for tomorrow. Yes, that is not extrapolation because tomorrow is not beyond the scope. And if you want to predict the gas price for Tuesday, Wednesday, Thursday, this is still not extrapolation, although it's 2, 3, 4 days from now. because it is still close to the scope. But if you try to predict the gas price 4 months from today, or 6 months from today, a year from today, that is what we call extrapolation. Means you have to go beyond the scope in this case. So how do you figure out if you have an extrapolation or not? It's very easy. Is you find the mean x first, and then you multiply that by 2. Okay, so in order for you to find this, you find the mean x first, and then you multiply it by 2. So that is the scope that you can have. So if that scope goes beyond that mean x times 2, we call it extrapolation. You will see some examples. I will show it to you. Okay. So if you fulfill all these 3, then we call this as a good model. But what happens if one of these does not satisfy, which is we call it the bad model or not good model? Then you have to use mean y. So in the R, you just type mean y, and that will be your answer. So that means that if I give you an equation like this, don't simply just plug x into this equation and that's your answer, because that is only work when you have a good model. But if you have a bad model, you just need to do mean y. Okay? And make sure that not a straight pattern means that if you draw a scatter plot, if your scatter plot shows a parabola like this, you cannot use this chapter tab. Okay, you just need to tell me that this is not a straight line pattern, and you cannot even do the y equals the regression equation. You cannot do the linear regression line, the correlation coefficient. That all has to be linear. So now we're gonna do R here. So this is something you need to watch out when you guys do R here. Now remember last time when you guys use a read table, in your R, I always call you to use x equals to read table, right? This is no longer x, this is A. So you have to do not use x here. If you use x equals to read table, you will get everything wrong after that. So that's the reason why that when you guys do your R, make sure you use A read table, not x, not y. You can use B, you can use C, you cannot use x and y here. And then you do x equals to A minus sign, what is the first variable you have to write? And then y equals to A minus sign, the second variable. So this is how you write your answer, how you identify your variables here. So do not use x equals to read table, use A, very important. Then plot xy is to draw a scatter plot, and then summary LM yx. Now, if you switch the yx around, you will get mostly everything wrong. So make sure it's yx first, don't switch this around. This is how you find all the goodies. And when you type the summary LMYX, this whole table will pop up. So what is important, I'm gonna highlight for you. This is important, this is important, yep, this is important, this is important, and this is important. So those are the few things that is important in this case. This 2 that I highlight is your y-intercept and your slope. Okay, this is if I want you to find a regression equation, you will use y hat equals to 108.55 minus 0.006703x. So this is your regression equation here. Okay, this is called your test statistic. So if a question wants you to find test statistic, this is your test statistic in this case. And then these are the same. These 2 are what we call as your p-value. What is p-value is used for? P-value is used for to conclude if there is a linear or there is not a linear correlation. So if this p-value is greater than 5%, then you conclude that it's not a linear correlation. If this p-value is less than 5, we should use 5%, then it is a linear correlation. And the last one here is your multiple R squared. This is how you find your R. But this is an R squared. So in order for you to find the R, you have to take the square root of it. And every time when you take the square root of it, you have to put plus minus. And how do we know which one to pick, plus or minus? It depends on your slope. If your slope is negative, like this question, the slope here is negative, then you will have to use negative. If your slope is positive, then this is a positive in this case. Okay, so it depends on your slope here. So it's very important for you guys. In R, if you want to do square root, you just put SQRT. I think you guys know that, right? So in R, square root is SQRT. This is square root in R. Okay. So let's take a look. So this is how we do this question, this chapter 10. So let's take a look at some homework. And I know someone really asked me for 10.6 question, 10.1 question 6, right? Someone asked me that question. Yep, 10.1 question 6. Again, this is your last Zoom meeting. We will not have any Zoom meeting after this. You will have a test tomorrow. Same thing, 13 multiple choice and 2-3 open-ended. It will consist of chapter 8, 9, 10. And then after that, the next Monday, you have your finals. Okay, you will have finals on next Monday. Your finals is all 50 multiple choice question. For multiple choice question, you do not need to show me a lot of work. What you need to do is you just need to show me, I want your answer A, B, C, D, E. Okay, so if you want to show me, usually I want your answer more than your work here. So let's do this question 6 here. So let's do Notepad here. You need to enter your data into Notepad. So now, how do you enter data for this kind of question is, these are given you by coordinates. So you have to use coordinates to figure out. So you have the X coordinates and Y coordinates. So I put X and Y, make it easier. So, so you have to give a coordinate. So if you look at the first point, let's take a look at this point. This is the point that we have. So what is the coordinates of this point? Anyone know what's coordinates for this point? X in this case is what? Y in this case is what? Anyone? What's the coordinate? 1, 1, yes. So that means your X is 1, your Y is 1. That's what you put in R. Now let's go up this point, the one above 1, 1. What is the coordinates of this point? 1, 2. So you do 1, 2. This is how you're going to do your R. And then the next one go up is 1, 3, right? And then you go the one on the bottom, move on. So what is the coordinates of this bottom point? This coordinate is 2, 1, right? Yep, that's what you do, 2, 1. Make sure you use a tab to do that. And then go up will be 2, 2. And then up will be 2, 3. And then you repeat this again. This is 3, 1. This is 3, 2. And then this is 3, 3. And now we got this one, the final one. What is the coordinate of this point, the very top part end point here? Anyone? This will be 9, 10. Yes. So you do 9, 10. Okay, now we got our coordinates. So you save your work. I'm going to do chapter 10.1 here. All right. So, and then you look, take your R out. And then don't use X equals to read table. Don't use that. Use A equals to read table. Because if you use X equals to read table, you will having a lot of difficulty. Okay. And then you pick the file name. I think I save it under my R file, chapter 10.1. There you go. And I want you to press A, enter. So this will match with your coordinates we have here. So what is this question? And then assign before. Assign a variable. X in this case is equals to A minus sign X, because that's your X variable. And then Y equals to A minus sign Y. So this is how you figure out. So X will have all these numbers, 1, 1, 2, 2, 3, 9. And Y will have all these numbers, 1, 2, 3, 1, 2, 3, 1, 2, 3, 10. So this is something that you have to do first before you, that's why I do this first before I read the question. So now we can read the question. So what's the question want us to find? Does these data points appear to have a strong linear correlation? So this one wants a linear correlation. So in order for us to do the linear correlation, you have to type in summary LMYX. Okay, so you have to type in summary LM Y and then the little mustache sign X, and then you have to have 2 closing parentheses here. Okay, so this is all we, again, this picture is the same These are all the results. But in order for us to find R, you have to square root him. Okay, so take the square root of 0.7972. It becomes 0.89. This is your R. So this is kind of what can you consider? So if you remember the notes that I have, if you get this, is your R is between 0.9 to 0.7, 0.6 to 0.4. Which one is your R between two? Your R is 0.8928, right? So which one should we use? This one, right? And what we call that kind? Weak, moderate, strong, perfect. Anyone? That's strong. Yes, this is strong because your R is between 0.7 and 0.9. This is strong. So what's the question asking us? You say strong, right? So do we have a strong linear? The answer in this case is yes, we have a strong. Okay, you say strong. What is your R? We just copy down. Now, do not forget that look at your slope first. Is the slope positive or negative in this question? Look at your x here. Is your slope positive or negative? Your slope is positive. That means your R will be positive. So it's 0.893 decimals place, 893. Okay. If your slope here shows negative something, then you have to put a negative in front. Okay. Now we look at your p-value. Where is my p-value in this case? My p-value is this number, 0.00050056. Is this p-value less than or greater than alpha? Alpha is 5%. Is this p-value less than or greater than alpha? It's less than. So again, if you look at my notes here, if your p-value is, there you go. If your p-value is less than alpha, there is a linear correlation. You see that? So since you say it's less than, so there is a linear correlation. So we will say yes, because the we call it critical region. So so how to read critical region is I shouldn't ask you that. You looking your if you is less than alpha, this is there is a linear correlation. Yes, there's a linear correlation because it is in the critical region. P-value should be in the critical region. I think it's B. Usually I don't ask this kind of questions. I will just say that is usually you just answer that is linear correlation, is because we don't ask the critical region here. So so if the yes, if you ask for if you do your online homework, if it's a critical region, then your answer is in. If you answer no, then it is not. So either you answer B or C. Either that is in the yes or no. But since this p-value is less than alpha, so it is a linear correlation. You guys all right with this kind of questions? Now the question asks C. Now the question wants us to get rid of 9, 10. So what you do is you go back to your notepad. You got your 9, 10 here. You just delete it off. And then you save it again. Okay, so go to your notepad, do 9, 10, and then what you do here is you go do the same thing. You do the read table, and you pick up the same one that you have. The difference between the one that you have is now the 9, 10 is no longer that. Okay, you still need to assign your x and y here. So your x ax and x ay. Don't forget that. And then the question wants you to figure out what is your R in this case, right? Yep, what is your R in this case? So you do the summary LM. And R in this case this is your R. Do you know what this number is, anyone? Anyone know what this number is?
Exponential, it's times 10.
Yes. So this is actually is 0.000000032 of the zeros, 32 of them, 32 zeros. I don't count. And then 8217. This is the meaning of this. 32 zeros. It's not 32 here. 8217. So how do you do this is you take the square root, the same thing, 8.217 e minus 33. So you just type in exactly the same as what your, the R shows up. This one is very small. So what is your answer in this case? If you have an R that is so small, your answer here will be what? 0. Because this is actually is close to 0, or 0 plus in this case. Okay. And then the last question is saying that what is your correlation coefficient? Your p-value in this case is 1, right? And 1 is greater or less than 0.05. 1 is, anyone? Someone asked something. So do we have to worry about critical? No, we don't. You do not, Jennifer, you do not need to worry about critical. We don't do critical region in our test. So in our work, so do not worry about that. So 1 is greater. So refer to my notes that we have just now. So if 1 is greater, so we conclude what? There is no linear correlation. So in this case, your answer, it will be, there is no linear correlation. Where's my little part? There you go. So no, because it's not in the critical region. Yep. So do not worry about the critical region in the test. Usually I will ask you either there is or there is not a linear correlation. So we don't care about the critical region. We care about p-value and alpha in this case. Okay. And now the last part is, what do you conclude about possible effect on a single pair value? So what happens to this 1 point? Do this 1 point change a lot, or does it not change a lot? It changed a lot. So in this case, a single pair does not change or change. So in this case will be the second one, right? A single pair can change a lot. So this is how we do the answer in this case. Okay. All right. So this is how we do these questions. 6. T is asking me is, what if the predicted is extrapolation? Do we consider? Yes. If you have an extrapolation, it's considered bad model. So that means if you try to predict like 3-4 months from the gas price from today, it's considered extrapolation, it's considered bad model. So you have to find mean y. Will we have to draw scatter plot on the test? Yes. How do we draw scatter plot on the test? It's very easy. So you use your R, like this, your R. You do plot XY. Plot XY will draw you the scatter plot. So this is a scatter plot that you have. Okay. So in the test, what you do is you right click this, and then you can copy. Okay. So when you guys do this in the scatter plot, what you do here is you do plot XY. This is scatter plot here. Right click it, you can copy or save. I should copy it. And then you open any Word documents or any documents that you have, and then you paste it. Okay. And then you paste it. There you go, paste it, and you guys will get your scatter plot here. You guys with me? And then you can make it smaller too. This is a bit big, but you guys know how to make it smaller, right? So just make this smaller. There you go. So, and then you can, then after that you include this. This is for, I don't know. So this is for the people ask me for tests. If I want you to draw a scatter plot, this is what you do is copy and paste, and then you just put out here. This is for what? This is question scatter plot question, I don't know, 17A example. You guys with me here? So I'll just put your name down and then put it down, and then you can send this to me together with the test. You guys with me here? So if I ask you for finals or any test that regarding that you had to draw a scatter plot, just do this for me. Okay? Everyone good with this? So just copy and paste on here. Okay, either one is fine, doesn't matter. So let's take a look at your other homework here. So do you guys have any homework questions? All right. If you do, type on the chat so I know what's going on here. So for this kind of questions, usually the first one is your X and the second one is your Y. So what you do here is, because I'm lazy to type, so I just put in here and I open it on stack. I copy in clipboard, and then I copy here, and then I paste it into here. I'll just get rid of this and I paste it here. Anyone know what happens if you save this and run R? You get an error message. Anyone know why you get an error message here?
Points.
Not points. The points is good. Decimal point is good. Not the decimal points. Yeah.
No X and Y.
The title is too long. Look at this title. You can only have how many letters? You can only have up to 6 to 7 letters. Yes, too long. So you have to make it shorter. So you can use scan. Oh my God. No. Something wrong. Okay, sorry, that's my computer. So you had to change it short. So you had to change your internet, and you had to get rid of this to award. So make sure that you have to change it into smaller like this. Then you save it. Okay. You guys with me here? And then what you need to do here is you have to go to your R. And then don't forget, not X equals, is A equals. And then 10.1 that I saved. So I want you to type A, enter, so that your notepad data, same with this. Okay. Now the question wants us to draw a scatter plot. So you do plot XY. Oh, you know what? I forget to label your X and Y. That's why it's so weird. So X in this case is not AX, it's gonna be inter. And Y in this case is gonna be award. Now we do plots XY. So this is the scatter plot is, and you can just mix and match with the multiple choice because this is a multiple choice. So which one looks like him? Looks like A, right? Looks like A here. Okay. Do you know what happens if you switch your Y, X around? If you put Y and X, your scatter plot looks the same? No, your scatter plot is different. See that? So please watch carefully with your variables here, because X, Y, and if you interchange your X, Y, and Y, X around, you find out that a lot of things are gonna be wrong. Your scatter plot, everything is wrong. So make sure you guys watch which is X, which is Y. This is mostly one of the mistakes that students tend to make in the test is they switch. How do you know which is X and Y? It's very easy. The first top line is always X if you're giving data, and the second one is always Y. Okay, or sometimes they will tell you which is X, which is Y here. Now you need to find R here, correlation coefficient R. So in order for us to find R in this case, you have to do the summary LMYX. Okay, so what you do with this, when you find the summary LM for this, you take the R, multiple R square here, you take the square root of it. If you have a calculator, you can use your calculator. Make sure you know where your square root button is. Square root of 0.6413. So you get this one. So that will be your R in this case. So your R will be 0.78384. Again, if you guys don't know how many decimal places you round in your test, 3, 4, the more the better, but don't give me a lot, 3 or 4 decimal places. 2, 3, 4. Don't give me 1, 2, 3, 4 is what I'm asking for. Your hypothesis statements, this is always equal and this is always not equal, 0, 0. So when you do your hypothesis statements, we don't do less than, we don't do greater than like last time that you did in chapter 8 or 9. This is always equal, not equals, and it's always 0. Okay, so this is fixed. You cannot change it. Okay, this is fixed. And then the test statistic. The test statistic is this one, 2.524. This will be your test statistic, 2.52. Okay, and your p-value is going to be this one, 0.065. Okay, next to it, 6.5, 3 decimal place, this question asking you. And then you figure out if your p-value is less than or greater than your alpha is 0.01. So your p-value is what? Less than or greater than alpha in this case. Greater, so coefficient is greater than alpha. There is or there is not when you have greater than alpha. There is not sufficient evidence for the correlation. Okay, you guys all right here? Femi, is that question 9 on 10.1? Femi, question 9 on 10.1. Okay, this is question 9. Okay, so now they got give you all 3. So so now you have to read the question. I didn't even read the question last time. I just go for it. So police sometimes measure shoe prints with crime scene. Listed below are shoe prints, foot lengths, and the height. Construct a scatter plot for this. Okay. Okay. So let me copy this again. Copy, and then paste it to Notepad. Again, the problem is they are too long here. Your title. So you have to make it short. So I'm gonna do shoe for the first one, foot for the second one, too long, and height for the last one. I think height is okay. 246. Yeah, height is okay, right? So save this. So this is we got it done. So how do we know which one do we use here? Which one is your X? Which one is your Y? Femi, do you know how you know which one is your X? Which one is your Y here? Do you know which is X, which is Y? It's given in the scatter plot. Look at all these scatter plot. Your X is your what? Shoe print. And your Y is your height. So we are only concentrate on 2 variables, shoe print and height. You are right, T, that is correct. X is shoe print, Y is height. So again, you use the same thing. You have to do the plot A read table. Then pick the file name A. X in this case, not Y. X in this case, as you remember the homework here, X is your shoe print, so it'll be shoe, and Y will be your height. So we do shoe first, and then Y will be your height. And then the rest is, you guys, Femi, you know what to do next after that? Because we're gonna go to 10.2 now. Femi, are you okay doing here? Okay, yep. So make sure that sometimes they give you multiple ones, then you look at the scatter plot. Sometimes they will tell you which one is which. So I won't give you that 3 of this. I'll probably give you 2 of them. Okay. So usually that's what we will do. That's what I will give you 2. Then we'll do question 13, 10.2. Yes, I will do that. Yep. All right. This is end of 10.1. So 10.1 doesn't ask you to do don't ask you to find the y equals mx plus b line, but 10.2 will be, and then all the other stuff will be there. So let's go to 10.2 here. This is the last question. That's it. No more Zoom, no more anything. This is your last one, and then you got another test and the final. Then you're done. Okay, what question is it? 13. Question 13. All right. This question 13 is asking for the bugs chirps per minute in different temperatures. The question wants you to find the regression equations, and then after that, they will ask you to predict something. So, yep. So this is, again, copy and paste. Don't need him anymore. Again, this is too long, so I do chirps for this, and the temperature is too long, I do temp. So make sure you guys have a short file name, titles here, so that it will, I'll just stay back at 10.1 here. Okay, so again, in your R, we do the same thing. A equals to, make sure it's A. Pick the file name, just double check. Yep, this is chirps and temp. So if you look at your date, chirps comes in first, that is your X, right? And then temperature is your Y. So in this case, X in this case is your chirps, CHIRPS, and then Y in this case is your temp. Okay, just press X and Y so you know that they are the same before you go on. What is this question want us to do? They want you to find the regression equation. So you do the LM, YX here. Summary, LM, YX. Make sure it's YX here. So this is it. Now with this, you can give me the equation for so the equation comes from your intercept and your X. This is your slope. So this is there I need 4 decimal place, 28.9597. This is 4 decimal place. And this is your slope with the X, 0.0518. You guys all right here? Oh, let me see. 5.1. Oh, round in 2, round the X coefficient in 4, didn't read the question, and round the constant. This is the constant. So constant, you need 2, so picky. So this is 2, and then the X slope in this case is 4. 96, yep, that's correct. Yep. So it's just read the question carefully. It's just that they are just very picky here. So next, you have to find the predicted line in this case. So in order for you to do the predicted lines, you have to fulfill that 3 condition, right? So what is the 3 condition that you have to fulfill in this case is 1, scatter plot have to show straight line, linearity. 2, your p-value has to be less than alpha so that you have, that is correlation. And then 3, no extrapolation. So these are your 3 conditions. And if you fulfill these 3 conditions, it's good model. So let's see what happens. So first thing is we have to draw your scatter plot. So your scatter plot hopefully does not show any curvy line. So let's do a like parabola type. That's my, there you go. And my scatter plot is hiding behind here. Where is my scatter plot? Where are you hiding? Oh, there you go. I put it. There you go. Too big. There you go. Yeah, this one shows kind of. I mean, I know this is considered a bit outlier. Yeah, it's good. So so in this case, this is considered. So this is good. So when you look at this, this is good. Check. Okay. Next, look at your p-value. Your p-value is 0.006. This is the p-value. And what is the alpha given to us? Oh, the alpha didn't provide. Oh, there you go, 0.05. If alpha did not provide to us, you use 5%, 0.05. What, 0.006 is less or more than 5%? 0.05. 0.06 is less. Okay, yeah, you guys are good. So less means, look at my follow. Oh, less. So this is also check. Okay, now extrapolation. So in order for us to figure out extrapolation, they want us to figure out 3,000 chirps. Okay, so let's take a look at mean X. Mean capital, sorry, no capital. Mean X is 1,003. And if you take mean X times 2, this is 2,000. And you try to predict what? The question is trying to predict 3,000. So that is considered extrapolation. So this is bad. Okay. So it because the maximum you can go is 2,000, and this question wants us to go to 3,000. That's why the question asks us to predict 3,000. So that is considered extrapolation. So this is a bad model. So if it's a bad model, you have to find mean y. So in your R, you just type mean y, and that is your answer. So your answer in this case is 80.92. 95, sorry, 80.95. Yeah, I know that's a mean value. Oh, one decimal place. Doesn't read the question carefully. That's me all the time. So it's 80, 81. If it's in one decimal place, 81. Eh? Yeah, 81. I know we're doing round one decimal place as needed. Something wrong with this one. You guys got this question? This problem? Yeah, it's 81, right? Should not be 80.9. Okay, I'm gonna try 80.9 for the heck of it. Eh? This is something wrong here. Why did you get 184.4? Huh. Should be 81. There's no way you get 180. Oh, they just want us to plug this in. The right answer should be 81. Yeah, don't use this question is a bit weird. The right answer, the reason why this is wrong is because so what they do is they plug 3,000 into this equation. Okay, what happened is they plug 3,000 into this equation. That's why it's so weird. So if you plug 3,000 into the regression equation, the regression is given as this one, right? So if you plug this over there, I know what's that. What happens here? It should be. So if you plug, where's my regression equation? 28.96, 28.96 plus 0.0518 times 3,000. That's where they got a 184.4. Okay. Usually in the test, I won't ask you that. I 181 is your answer. Why this is considered wrong? What's wrong with this? It is unrealistic high because it is far beyond. So this answer is B here. This is called extrapolation. So I don't know why they ask you that. And then they'll probably ask you the correct answer. Nope, that's it. Okay, so usually in the test, let me go back to that question. Usually in the test, I won't ask you that number, 184.4. Yeah, I will give you 81. In the test, I won't ask you this question. I will ask you what is the best predict line predicted for this case, and your answer in this case should be 81. Okay, I don't know why this answer gives you 184.4. So it should be 81 in this case. So please ignore, we don't do this kind of questions like this in your test. If you give me 184.4, I will mark you wrong. You won't get full points here. Your correct answer should be 81. Okay. So T, are you okay with that? Yeah, it should be. I don't know why they plug X over there, but the correct answer should be 81 in this case. So don't forget that if you did not fulfill, if it's a bad model, you have to find the mean y. If it's a good model, you plug it in. And this is a bad model because of extrapolation. Anyone have any questions here before we end the Zoom session, because we are almost out of time here. We've got a few more minutes. So your test is tomorrow. Your test 3 is tomorrow. You got 24 hours to do it. You got around 13 questions, noon. I will send it to you by noon. You can check your email or your D2L for the test. No, we cannot do the test on Wednesday. It will be Tuesday noon, and you got 1 day to finish it, and then you give it to me on Wednesday noon. Your final is on Monday, not Tuesday, Monday noon, and it's all it's a 50 multiple choice question. Yes, Michael, you're right. Mean X Type 2 is a scope, and 3,000 is out of the scope. You are correct, Michael, you're correct. Your final on the finals, are the questions going to be ordered in chapters? No. Linda, the finals, your questions is all going to be mixed up. So it's not going to be ordered like chapter 1, chapter 2, chapter 3. It's all going to be mixed up here, but it's going to be 50 multiple choice question. So your test will look something like, so this is what happens in your finals. In your finals, let me show it to you. Where is that at? Not this one, sorry. Test. That's my final. No. Your finals usually is all in the multiple choice, so I do not. It's not in here. Sorry. So I thought it's in here somewhere. Cannot find. So anyway, your finals is going to be multiple choice. I think I told you guys how to do your finals, right? I just want your answer. Like the first question is A, the question is C. So I just want your answer in your finals. It's all 50 multiple choice. I do not want you guys to give me your work or anything because I have a lot of papers to grade finals. So make sure that you do this. It's very easy. What do we suggest to recommend to study for your finals? All your tests, test 1, test 2, test 3, all your tests. Okay, I will recommend you to study all your tests because it's mostly multiple choice question. Again, all 50 multiple choice question. So study all your tests. Okay, all 3 tests. That will be something I think I also will post final reviews. I think it's already in D2L, the finals review. So go to your D2L, go under the content, and the final review is in D2L. So I would suggest you guys to, and that's a key in that. So do the final review in D2L, do all your tests, and no, there is no lowest test score here. I don't drop any lower test score. I wouldn't drop any. The only thing that I drop is 2 lowest online homework score. That's the thing I would drop in this case. So for tests, should we show work? Yes. The showing your work is up to you. Okay, Pazon. If you want to show your work in multiple choice, it's up to you. So you understand how you do that. So in test 3, if you want, you can. But in the finals, I don't want to see. You don't show the work. You just give me A, B, C, D. But test 3 does have open-ended questions. So make sure you guys know that test 3 does have open-ended questions. You have to write it out. And again, class, download Cam Scanner in your phone because I can only accept 1 PDF file. So if you send me multiple PDF file, if you send me a JPEG or a picture file, I will reply back to you and say I won't accept this. You have to do it. So there is penalty for not showing your work because your test 3 is like test 2. That's open-ended type. You have to show your work. There are multiple choice. The multiple choice, I don't care about the work, family. There are open-ended in test 3. It's like test 2. You took your test 2, right? It's exactly the same. Your test 3, you have the 10, 15 question open-ended, multiple choice, and 3 open-ended, 3, 4 open-ended. That one, the open-ended, you have to show me your work, and your work is a lot. Your work will be like covering like something a lot. You have to write a lot of work. So example is it will be something like if you do your hypothesis testing, if you remember, you remember how you do your hypothesis testing? So you have to do quite a bit of work there. So this is what it will look like in test 3, where you will get a question like this, and the rest is blank. So this is what test 3 looks like. You get something like this. This is what test 3 looks like. That's it. So there are open-ended part that looks something like this. You have to show me all the work here. Yes, this one worth 15 points in your test. So you do have to show me the work. And there are multiple choice questions. That one is up to you. That's why Pazong asked me for multiple choice question. Do you need to show the work? That is up to you. But there are open-ended questions like this. You have to show me the work. Otherwise, you get 0. That's easy for me to grade. Yes, there are works you have to show. Okay, except for finals. Again, multiple choice question, up to you. If you want to show me your work, it's up to you. Open-ended questions, you have to show me the work. Okay. All right, so that's it for today. I'm late for the other Zoom class here. So if you have any questions, let me know. Send me emails. That's the end for today's Zoom session here. I will post in D2L and make sure you guys watch the Zoom session here. All right. So any questions, email me. I will see you guys. This is the last Zoom session, so make sure you guys send me any emails. All right. See you then.